Hi, I'm Scott Bland, course champion and author of the Low Power RF Solutions Workshop. If you're considering taking this class, I'd like to take this opportunity to go over a little bit of the agenda with you in more detail. Module 0 is a welcome where we basically meet and greet each other and find out what some of our basic needs are that may outstrip what the class is actually doing. In Module 1 is an introduction to the architecture and the different players and parts that we'll be working with during the class. Module 2, the IDE tools, is about IAR Embedded Workbench. If you haven't had a chance to work with IAR Embedded Workbench, we'll get a chance to do that in this part of the class. If you have worked with it before, this will just be a review. In Module 3, we'll be working with the MSP430 programming, some of the better techniques for working with that microcontroller. The MSP430 is a product line from Texas Instruments. We'll be using 2 of those. All of the different protocols in the class are programmed on and utilize the MSP430, a couple of different parts. In Module 4, that's the RF basics. We'll deal with packet error rate testing, range testing, some other stuff so we can understand what's going on with the antennas and a little bit about the RF for working with over-the-air wireless devices. On day 2 of the workshop, we'll start off with simplicity in the morning. Simplicity is the non-802.15.4 protocol of the one of 4 that we have at Texas Instruments. It works on 2.4 gigahertz radios. It has peer-to-peer and star-type topologies. We'll deal with all the different ways to set the network up. We'll actually, in one of the labs, one of the 3 labs, we'll take a given user application, temperature sensing application, and we'll make it remote by adding simplicity from scratch to the application. For those of you who are only taking the simplicity course, portion of the course, at the end of this module, you'll be able to leave, take one of the simplicity boards with you, and you'll be free to go. For those of you who are staying for the 802.15.4 portion of the workshop, we'll begin on day 2, after the simplicity part, with the operating system abstraction language and the hardware abstraction language module. All of the other 802.15.4 protocols from TI, TI-MAC, Zigbee, and ZXL are all built on these baselines, these foundations. So we'll have to cover those. In Module 7, we'll do a lab and a module on the TI-MAC. The TI-MAC is the basis for Zigbee and ZXL, implements a simple peer-to-peer and star-type networking, and that's what we'll cover on day 2. Day 3 is completely devoted to working with Zigbee. In the Zigbee part of the class, we'll talk about mesh networking, routing, addressing, end devices, endpoints, descriptors, everything that you're going to need to know to work with Zigbee. We'll cover 4 different labs, working through as much as we possibly can, utilizing the generic app sample application that comes with the Zigbee workshop. On day 4, we'll start out with ZXL. ZXL is a repackaging of the Zigbee stack into the CC2430 as a pre-programmed device. It's paired along with a microcontroller, in this case an MSP430, that runs the application side, while the CC2430, which has been renamed and numbered the CC2480, that device handles the complete Zigbee stack. In Module 10, we'll deal with Zigbee security and the AES-128 module that's attached to the device. In Module 11, we'll talk about manufacturing issues, IEEE addresses, production programming, Zigbee Alliance membership. In Module 12, we'll deal with additional issues, in this case, locationing. Module 13 is the wrap-up and summary. Thank you very much for watching this. Good luck with your project.